Waltham, creator of very nice watch movements and one of the most influential watch companies to have existed. Now, unfortunately, my watch on the bench is not one of them. In fact, despite what it says on the dial, it's not really a Waltham at all. Now, Waltham itself was the company that saved the American railways from disaster. It's even said to be the inspiration for Henry Ford's production line process. Ford visited the Waltham factory 3 years before production started on the Model T. Abraham Lincoln owned one, although he ended up giving it to his cousin, who was mugged on the way to the White House. So it seems like not a lot has changed around the Washington area. It's a brand so American it was simply called the American Watch Company. I'm surprised they all don't play the Star-Spangled Banner every time you wind one up. Now, Waltham may just be one of the most American companies I've ever heard about, so why does mine have Swiss made written on it? Well, we'll get into the history of Waltham and its fall into becoming another generic Swiss watch brand in due course. However, our journey through this video doesn't actually start with this watch, or in fact the Americans. It starts instead with the communists. So it looks like we might have inadvertently discovered the cause of the Cold War here, as it appears that the Eastern Bloc were well on the way to discovering AI technology back in the 1960s. However, judging by the wiring in this thing, they had a little way to go. Now, this is my small parts cleaning machine, watch cleaning machine, if you like, and it came with a few issues, as you'll see, one of which was the motor promptly exploded as soon as I turned it on. Now, these machines have a small problem, not the least of which is the new ones are frighteningly expensive, starting for the Swiss ones at around $3,000 and going upwards to $20,000, $30,000. And in my opinion, at that price point, they're not very good. So I set out to create a platform for small parts cleaning that would allow you to CNC old machines like this and then build new ones from scratch for a fraction of that cost. But of course, in order to do this, we're actually going to need to design a hardware controller to control the 3-axis machine, heaters and a motor. We're also going to need to write the software for that controller. Now, I don't mind telling you this project has been driving me out of my tiny mind, but I really wanted to open source and open hardware a small parts cleaning machine platform that would allow you not to have to spend $3,000. So I'm going to start with this cleaning machine as a basis, which I bought here in the Czech Republic where I live. But to be fair, the hardware and software that I'm going to create for this machine could be used with a bit of old plumbing pipe and a way to mount a motor. It should certainly be a good starting point for anyone who wants to create one of these or update an old one that they have. So we're going to get in here and take a look at the electronicals, which I'm sure are going to be fairly frightening. Now, of course, this thing came with a lot of free dirt, which is always nice to see. And as you can see, the wiring in here is pretty simplistic. Now, one of the other problems these older machines tend to have is we use modern solvents now to clean small parts which evaporate and don't need to be cooked off with a massive ceramic heater. In fact, you really don't want to be heating up small metal, very delicate, very precise parts to insane temperatures. What's generally done now is air-assisted warm air drying, so that's what we're going to do with this machine by the time we're finished with it. No need to cook those parts anymore. There'll also be room on this for heated cleaning fluid, and there you can see that massive ceramic heater and the pretty simplistic, frankly quite scary wiring in this thing, although they did do a reasonable job. So I'm going to let you watch me disassemble this in the background if you're interested in that sort of thing, and I'll be back when we start to create both the hardware and software platform for a small parts cleaning machine. Right, so this seems to have come apart fairly well, apart from this heating pipe here, which I believe is just an interference fit. It's just friction fit. But I don't want to whack it with a hammer too early, although probably we're going to need to use the old persuader, because what's the old adage? When all you've got's a hammer, everything begins to look like a nail. So with this machine apart, we're going to now need to strip the paint off it and clean it up, something I'm not looking forward to because a lot of this stuff was old lead-based paint and I don't really want to sand it. Okay, I'm going to spare you any further stripping, and pretty much all stripping in the future will be reserved for my OnlyFans. Now this cleaned up pretty well. We've got the machine disassembled here and clean and ready to go. Of course, we now have to create an entire hardware and software platform to get it to work, so we're going to see this. But before we get on with that, I want to take you now from the communists back to the Americans to discuss the history of Waltham and why the one on my desk, well, isn't. Let's get this thing apart so we can see what it is we're dealing with, and we've already started to find rust, which is generally not a good sign. We do, however, have bigger fish to fry on this watch, as the winding stem is completely stuck in there where the crown has snapped off, so we'll have to extract that. You also might be able to see on the dial that some of the hour markers are quite wavy, especially around the 4 o'clock position and down by the small second there. This is because this watch has been underwater, I believe, at some point, and those hour markers have actually floated off, so even the ones that look good actually aren't. The 1 o'clock on this watch is more like 12:15, so it looks okay in places, but generally it's not good whatsoever. Now, I had some trouble decasing this. It was quite stuck. And for those of you wondering, this movement is not American, it's an FHF.
Fabrique d'horlogerie de Fontaine-Melon.
Now, I'm no expert, but that doesn't sound very American to me. FHF actually joined forces with a Scheele in 1926, along with another Ibush manufacturer, a movement manufacturer basically, to form Ibush's SA, which today is simply known as ETA, which of course is owned by the Swatch Group. Now, the funny thing about all this is in the 1800s, Waltham were the standard for accurate, cheap watches. Well, not necessarily cheap by today's standards, but affordable by the common man. Waltham really were a household word in the United States to such a degree that the Swiss would create brands with names like Walham in order to break into the American market. And I can't help but wonder if some American walked into, ye olde tavern back in the day to show off his shiny new watch, and his friend went, "I'm pretty sure there's supposed to be a tea in Waltham." Now, Waltham itself started in 1850, and today it's really not as well known as it should be. Up until the 19th century, watch parts were made for individual watches rather than a series of watches as we do today. Now, this process was imprecise, time-consuming and expensive, and as a result, only the wealthy could really afford a timepiece. But no two timepieces could be relied on to tell the same time, and Waltham revolutionized this industry by developing extremely precise machines to produce standardized movement components that were interchangeable. Now, the company itself started in Boston in 1850 by a guy called Aaron Dennison. Now, after a visit to the Springfield Armory in Massachusetts, where he was thoroughly impressed by the efficiency and precision engineering in armament manufacturing, Dennison set about applying the same methods to watchmaking. Production soon moved to the city of Waltham, which obviously gave the company its name, and the assembly line methods used at that factory were reportedly the inspiration for Henry Ford, as I mentioned in the intro. Now, Ford visited Waltham in 1910, 3 years before he started production on the Model T in Highland Park, and he had a lot of experience in his youth as well, fixing pocket watches. So Ford fixed actual pocket watches before turning his attention to cars. Waltham's mass production significantly reduced the price of pocket watches. During the American Civil War in the 1860s, demand was going up as soldiers were looking for reasonably priced timepieces. After all, no one wants to go charging over the hill 5 minutes before everyone else. To meet this demand, Waltham designed a watch for Union soldiers called the William Ellery, named of course after the founding father who signed the Declaration of Independence. The soldier's watch became a tremendous success and accounted for almost half of Waltham's production. Now, one of these watches was gifted to Abraham Lincoln, possibly following his famous Gettysburg Address, but as the case was made from silver rather than gold, it ended up in his desk drawer. Now, his cousin Dennis recalled a visit to the White House where on his way he was actually robbed by a group of thieves who stole his watch. Upon hearing this, Lincoln retrieved his patriotic watch and told him, "Here's my watch, Dennis, keep that. They don't allow me to have anything like that here. I must have one like this," upon which he promptly pulled out a gold watch from his pocket, most certainly English-made. Following Dennis's death in 1892, the William Ellery he got from Lincoln moved between various museum collections until it was stolen from a display case at the Lincoln Savings and Loan. Slightly ironic, that one. In Los Angeles in 1977, its whereabouts to this day remain unknown. Another chain of events that catapulted Waltham's precision timepieces to prominence in the mid-1800s was the expanding railway that were becoming increasingly unsafe as the number of trains on the tracks went up. Between 1831 and 1853, there were 97 collisions in the United States. Many of these were caused by the inability to time the passing of trains traveling in different directions accurately. The problem for the railroads was simply too many time standards: Boston time, Springfield time, Worcestershire time, and so on. This led to train conductors setting the time on their watches by the time at their local station, which of course led to absolute chaos on the railways. Something needed to be done, and that something was the introduction of railway time. The first voluntary agreement was set up in 1853 after the Valley Falls train collision on a blind curve known as the Boston Switch. It killed 14 people and was due to a faulty watch which was running 2 minutes behind and a reckless conductor. The accident was actually captured on camera by Mr. L. Wright minutes after it occurred in what's believed to be the first photograph of a train wreck. Now, railway time became mandatory in New England, where it quickly spread to the rest of America. Now, the adoption of railway time and the move towards precision timekeeping meant Waltham, who produced watches that were both affordable and accurate, became a world leader in manufacturing timepieces. In fact, by the 1890s, Waltham watches were considered the most precise in the world. Every railway line in the US used them on their trains. Their precision instruments made the US railways a lot safer. It's also believed that the Swiss watchmakers sent spies to gather information on Waltham's engineering and production processes. However, they were unsuccessful and made what became known as Swiss fakes, replicas that looked like Waltham but didn't work like one, even as I mentioned previously, going so far as to print things like Waltham on the dial to mislead potential buyers. There were other names used by the Swiss during this time period as well. Now, there's a lot more to be said about Waltham, but unfortunately I have a limited time in this video, so I'm just going to say Waltham failed to adapt quickly to the changing market from pocket watches to wristwatches, and in 1952 Waltham surrendered to European manufacturing prowess and announced they would start importing complete movements from Switzerland that would be dialed and cased in America. This sentiment was shared by Waltham's competitors at the time, Hamilton and Elgin, who also went over to using Swiss movements around this time. Waltham was officially defunct as an American company in 1957, but it also set up a Swiss subsidiary in 1954, the Waltham International SA. It retained the rights to the Waltham name outside of North America and continued to produce mechanical watches and pocket watches under the Waltham brand. In the US, the Waltham name was sold to the Waltham Watch Company, which moved operations from Massachusetts to Chicago. They also opened a new factory in Switzerland in 1962, which produced about 100,000 watch movements per month. As this new company had little to do with Waltham's wholesome American image, it came under scrutiny from the Federal Trade Commission, which accused it of misrepresenting country of origin and connecting the new company to the previous Waltham Watch Company. In response to these complaints, they changed their advertising and branding before they were finally bought by a Swiss consortium led by Invicta in 1968. This consortium also purchased the rights to the Elgin Watch Company before it went under during the 1981 quartz crisis. Now, of course, the history of Waltham is more complicated and detailed than this, but that's about all I have time for, unfortunately. Now, our watch went together, the balance went back in for cleaning, and it's spinning superbly, considering the state that this thing was in. Now, before we throw this into some cleaning baskets, I want to take a look at it under a microscope to see the dirt we have on here. So you can see the jewels are encrusted, probably with dried on oil. This is not good. This will create friction, stop your watch from keeping proper time and working properly. There's also various blemishes. There's all sorts on this thing, and I'm not talking about the licorice type. I believe that's probably just dried on oil, some dirt, dust and schmutz that's got on there. We do have some scratches on the plating, and I want this comparison here so when we clean it in our newly developed watch cleaning machine, we can see an actual result. However, before I can do that, I need to get the pile of parts that's currently the cleaning machine off my workbench and back into one big part, and I'm going to start this process by vinyl wrapping the bottom platforms. Now, I like vinyl wrapping for this just because it's washable, it's easy to clean, and it's easy to change if it ever gets, a bunch of solvent on it. Now I'm going to spray the rest, and then we're going to get on with CNCing it by creating the hardware and software controller for it. But before we continue with the video, I have some bills to pay. So as I'm sure some of you will know, I am a bespoke maker of straps. I hand make unique straps, custom to order. Here's one that was for a Universal Genève with a custom monogram. And I use the finest quality leather and the finest quality, everything. Now, as I'm not prepared to sell you guys some dodgy mobile game or take bad sponsorships from Chinese companies, this really is the way I pay the bills. So if you're in the market for a high-end bespoke strap, feel free to check out my website. I'll link it in the video description. We use some of the world's best leather, and everything is made by hand by me personally. So if you want to support the channel, go and have a look. And now with that taken care of and nicely vinyl wrapped, let us spray. So the basis of our machine starts to come together here, and it no longer has paint on it that's been banned by the Geneva Convention, but this is of course only half the battle. At the moment it simply looks pretty, it doesn't actually do anything. We need to explore some options for how to get a motor on this thing, how to get controls on it, heaters, all of the business you actually need to create a small parts cleaning machine. So one of the first options I looked at and ended up dismissing was one of these. This is a Gerbil control board. It's used to control small CNC mills and small laser cutters, that type of thing. They're fairly ubiquitous. They can cost anywhere from sort of $25, $30 upwards of $100, depending on the feature set that you use. But I decided I was going to create this board from scratch so we can get a proper basis for a cleaning machine. Now, in order to do this, for the rough draft, I'll be using an ESP32 development board and a TMC2209, I believe, silent stepper driver, some fans, a stepper motor, and various other components, including this buck converter, which I'll build 2 of these into a nice little 3D printed box enclosure to give you all the voltages you need for the project, which are at the moment coming out of this multi-core cable. Now I'm going to wire this up. It's going to be a bit spaghetti and a bit jank, but it will give us the basis we need to start developing some software so we can get this machine back up and running. Now here's the software I wrote to get this all working. I'll spare you most of it. Well, that was easy. Now, let's see if we can get this motor to go ridiculously fast for a stepper. And indeed we can. We can control the direction changes. And the readout you can see on the small display is being read over serial from the controller. So those are actual real numbers. Now, I did want to be able to update this thing via Wi-Fi. It also has Bluetooth controls should you want it. And as I said, I'll be open sourcing all of this so you can go tinker with it yourself if you're of a mind. Now I've added an OTA update option to the main menu here. So I said you can update firmware over Wi-Fi, and we'll need to check that that's working. The system also features stall detection and load detection, or at least it will when I get round to writing it. So if your basket hits the side of a chamber wall, the system will stop. And as you can see, we can change direction, hit whatever RPM we're going for whatever length of time we need. But now let's put this thing into OTA update mode. You have to specifically do that with this because I don't want my cleaning machine connected to my network all the time. I really don't see the point. Now, we are updating just fine over the air, which means I don't have to muck around with a USB cable every time I want to do a firmware update. So with that done, let's just check everything is still working. You can see my cleaner has updated to version 1.1 with that over-the-air update. And we'll go ahead and we'll try a drying cycle here. Again, this cycle is just for demonstration purposes to show we can change the direction and hit a specific speed on the stepper. So this project has taken me a couple of months to develop from start to finish, from buying the machine to getting this far. But I really hope that it will help a lot of you with these old machines, or even if you don't have a machine, all you need is a way to put a motor on some sort of hold. Basically, you need to be able to move a motor up and down into a cleaning solution jar. You can see I've added the fan here. I didn't, unfortunately, have time to add the silicone heating pads. We're not going to need them right now, and I'll be updating the software and the hardware in the future. Now, talking the hardware, we of course need to design it because this is getting a bit janky, even for me, a bit spaghetti-like. So I'm going to go into a program now and design both the schematic and the PCB we can make. Now, I'm not great at this, so if one of you wants to pitch in and give me a hand, I'll eventually redesign this all as surface mount with a proper PCB. But for right now, we're just going to make one ourselves here in the workshop, just for development purposes. So I'm going to let you watch me build that PCB, which hopefully you'll find somewhat interesting. Alright, now we have the PCB from the design process into an actual real thing. It's time to take a look at putting the machine back together and making sure everything works. Now, this process was fairly simple. This is a fairly easy machine to take apart and put back together. And as I've mentioned, I think several times now, the goal of this project was to allow people with older machines like mine to update them to run more modern software and have more features like heating, drying, fan assist, and whatnot. Be able to update over the air, set your own cycles, your own timing for whatever suits your needs, as opposed to, just these old machines which generally had a control which was just, fast in one direction or slow in one direction or a combination thereof. So as this goes back together, it's smooth now. It was about as smooth as Egyptian whiskey when I first got it. So this is nice to see. Now, I've been very pleased with how this project is coming along so far. It's been a lot of work involved, and I'm really hoping by open sourcing and open hardwaring this whole thing, it genuinely gives people an opportunity to update these older machines or even build their own from scratch. I'm also hoping some of you out there who are better at hardware development than me, which wouldn't be terribly difficult, will jump on board the project and give me a hand. I'll leave all the links for the GitHubs and whatnot in the description. If you're interested in getting involved, just go look at the code, look at the hardware design, see if there's any improvements you might like to make. So most of the electronics for this project will go up this center shaft because I am relocating the controls for this machine from the bottom of it to the top of it. I don't really want a lot of delicate electronics hanging around right underneath where I'm going to be sloshing about, I'm sure. Lots of cleaning fluid. And also it's more comfortable to use with the controls at the top rather than hunched over at the bottom. Now there is the box with the buck converters in. This will be feeding all the voltage into our project. And I designed this with no high voltage electronics in it. So this box is just powered by a laptop power supply, 24 volt in this case. You can go lower, you can go up to 36 volts as well, which will give you a bit more grunt on your stepper motor. But if you're not comfortable with mains electric, and that's a discussion I'm not getting into on YouTube because all the safety sallies come out and the comments section turns into a horror show, rest assured that this whole project is 24 volt DC, which you can power from a simple laptop power supply. So no need for you to do any mains wiring if you're not comfortable with that sort of thing. Very safe project to put together in that regard. Now here you can see where our drying chamber would go on. I fitted the fan underneath it. There would also be a silicon heating pad underneath that, but they didn't turn up in time for the project. And as I mentioned, this has been a fairly arduous journey. I'm already on the verge of losing what's left of my marbles. So I decided to go ahead and fit this kind of demonstration version without the heating for the fan. But it has to be said, in modern drying of parts, we use warm air. So 30 to 40 degrees, not that much above room temperature. And that's in Celsius, by the way. Not that much above room temperature. There is no need to cook your parts. And with the solvents I actually use, with the cleaning solvents, the fan will dry them just fine. We are just trying to stop the evaporative drying from lowering the temperature of the parts that hit the dew point, so we form condensation. We don't want that, and the fan will stop that. So in my case, I probably will never fit the heater under the fan, although it will go into the final design. Just because I want to make a complete unit and give people as many options as they want for the specific cleaning fluids that they use. Also, there'll be a heater for the main cleaning liquid as well. Again, unfortunately, I'm not going to have time to show that here, but our machine comes together quite nicely, and it'll now be time to fit the electronics. So this machine is now smooth as butter. All it needs is some electronicals, because all we've got at the moment is the cable for the fan that goes up the middle and the cable for the power distribution that goes up the middle. Now, of course, with our wires going up the middle of the machine, we'll need somewhere to house all those electronicals. So I went ahead and designed this enclosure. This is intended to move the controls for this machine from the bottom to the top. Now it's a fairly simple thing. You can see there where the main shaft of the machine comes in. We can hold our PCB on these clips, and I won't bore you with all the CAD design. Just this is the enclosure we'll be using at the top of our machine, and our circuit board will sit here and all of our cabling and wiring will run into it. So here you can see that PCB we made on the top. There's the cable for the motor, the fan, and the power cable. Now I designed this board with connectors, so basically my old feeble brain can't plug anything in backwards. But it's just nice. It's very plug and play. It's easy to fit on the top of the machine here. And as this is whole development kind of thing, I will need to be taking this apart several times, I am sure, to continue its development cycle before it's ready for everybody else to jump on board. But as I've said, I will be making it available when this video goes live. So it'll be in a fairly alpha state, if you like. It will not be polished at all, but I'm sort of hoping that some people will jump on board and throw in their 2 cents too, and we can create an open source, open hardware cleaning platform for anyone that wants it, that you can build for a couple of quid. Because the bill of materials on all of this, not including the cleaning machine, has been about $40, somewhere around there. And if you can pick up a second-hand cleaning machine or simply find some way to hold the motor so it goes up and down, you'll be able to build one of these for next to nothing, with all of the modern features: heating, stall detection, load detection, air-assisted drying, all the business. But let's see if it works. That was the longest 2 seconds of my life, but we seem to be working here. There's also now, you can see, a setup mode on this that I haven't finished yet, but that will allow you to set your speeds and cycles and whatnot. But as you can see here, this works wonderfully well. Now I need to adjust the set screws on the motor coupler to get that a bit more concentric. The spinning basket itself is not round, so it's a little wobbly, but nothing you wouldn't see on pretty much any machine. So this has all come together wonderfully well. Let's try spinning it a bit faster. Now only 500 RPM. I have spun this and I will demonstrate it spinning at 1200 RPM. I do want some time to let the machine run in and figure everything out, because I have literally come into the workshop here and just fit this in. You're seeing this at the same time I'm seeing it. So I'm really pleased at the moment with what this machine is actually capable of. You've got the OTA update there, the setup, which currently does nothing. Let's put it up to 1000 RPM and see how we go. Not bad at all. And the machine is very, very quiet. But now we have something that looks like it might be able to clean a watch. Let's get back to the bench, put everything in some cleaning baskets, and see if our Swiss Waltham can clean up okay. Now, in most of my videos, I skip loading these baskets because it's a little uninteresting. But as this video has been predominantly about the creation of this watch cleaning machine, I thought I'd give you guys a look at how I stack these baskets. Now, I'm not being particularly careful here, and I'll load the smaller parts into smaller baskets. Really isn't a very complicated affair. These baskets, of course, will eventually interlock together in the cage arrangement you saw on the machine earlier. So that's it. That's all the baskets stacked. Obviously, I've cut a lot of that out because it's not too interesting. And now we move on to the cleaning. So I use this Elmer waterless cleaning, rinsing and cleaning agents. It's a nice cleaning fluid. I've had a lot of success with it in the ultrasonic. Hopefully I'll have more success with it now in the watch cleaner. So I'm loading the machine up with a couple of rinse cycles and a cleaning cycle. Now your mileage might vary, you might use different liquids at different temperatures and whatnot, and that's really been the whole purpose of this machine. Now as you can hear in the background, or at least I hope you can hear, this machine runs quietly, as I mentioned, and that was a big thing for me. Because I do most of my watch work as a hobby. I do it in my house, not in my workshop, and I often run this thing quite late at night, and I would not be popular with the neighbours had I left the original motor on this. But this is now running through a cleaning cycle. We'll put it through a rinse cycle and then a drying cycle. As we've seen, all of these cycles are fully programmable to length of time, speed, distance changes, directional changes, and whatnot. So you may need to alter that, and I may need to alter it, depending on what cleaning fluid I'm using. Now I do a quick spin dry here to get most of the fluid off before I dump it into the rinse liquid, because I don't want to cross-contaminate my liquids. Now this is a little noisier because it's running, I think, around 600 RPM at this point. And if the basket looks a little wobbly, it's because it is. I'm waiting to design a better coupler to the motor, but as they say, Rome was not built in a day. So here we go with a rinsing cycle. I'll do this in a couple of different jars with a couple of different rinsing liquids, just to make sure all the cleaning fluid is off. And of course, this will also aid the cleaning process. But now it needs to go into the drying chamber. The fan turns on here. And this, of course, will be a lot noisier because we're spinning at 1125 RPM at the moment. And that motor coupler is really not happy. But I will take care of that in short order. Comes out of the drying chamber, bone dry, which is exactly what you want to see. The combination of centrifugal and fan has dried that up wonderfully. Now here we get to take a look at some of the before and after shots, and I'm sorry I couldn't really get this synchronized, but I think you can see here that we have done wonderfully well. Now normally there would be a bit of manual cleaning involved, especially with the jewels. They would be pegged with a bit of wood to clean them, but I didn't do that in this case. I wanted to just see the raw output from the cleaner, and I am extremely pleased with the performance of this thing, considering I don't have it dialed in yet. Everything came up pretty clean, much cleaner than I have ever been able to achieve with the ultrasonic cleaner. You can take a look at the wheel before and after there, and again, apologies for not getting this synchronized, but I think the cleaning machine, being so old with the new electronicals and everything, did beautifully well. But that leads us into what I'm going to do with the Waltham. Well, for me, it was never a Waltham. The dial is completely banjaxed. The hour markers, even though they look sort of on point, actually aren't. You cannot tell time at all on this dial, and this Waltham means absolutely nothing to me. Now, of course, it would be possible to have it professionally restored, but to me, this just represents nothing of Waltham. So I am going to whip up a quick prototype dial for this watch, which I'll show you in a second, and I may continue forward with this in a future video if you are interested. So I am going to turn this Waltham back into what it always should have been, in my opinion, which is this lovely Swiss Waltham. And I genuinely hope that I'm sitting in a pub one day and somebody approaches me and says, I think there's supposed to be a T in Waltham. So that's about it for me. I may bring you the full build of this prototype dial. It's just a rough draft at the minute. I hope you found this interesting. Links to my workshop can be found in the description below if you want to go and buy yourself a very nice strap, along with the GitHub repository that contains both the hardware and the software if you want to update an old machine of your own or even build a new one from scratch. It was very nice to have this opportunity to talk to you all, and I'll see you in the next one.